Okay, welcome. This is summer semester 2022. What is this? Is the fourth week we've done this? Man, time flies when you're having fun. We got test coming up in a week and a half, so if you guys get any questions on that, holler. I am planning next Thursday. Tuesday I'll do the normal lecture on Chapter 6, which is user-defined functions. I read the text on that today. It's really cool. There are some updates. And then Thursday night, when I normally meet with my SolidWorks people, I will meet with you guys, whoever wants to come in, and I will work an exam from a previous semester, just showing you how I would go through and solve all these problems. So that will be next Thursday. Yeah, hopefully Thursday. That may change. I have an aunt that went into hospice care yesterday, and another aunt that's coming up to see her, and she wants to meet with me. And and if that's Thursday night, I got a family takes precedence over classes. Sorry.
Okay.
I think I'm recording. So yeah. So if it does turn out that I can't do it Thursday, we'll either do it Wednesday or Friday. Definitely we'll get it to you before the exam on the following Wednesday, Thursday. There was an announcement that went out earlier this week that said that the exam was Wednesday, Tuesday. I do the bestest I can when I'm setting this Canvas site up every semester. I just copy the previous semester and update it with new dates, and some things slip by like that. Okay, the exam will be on either Wednesday or Thursday at the testing center. The instructions to register for an exam are in Canvas announcements. It should have came in with that same announcement that said it was on Wednesday, Thursday, or Tuesday, Wednesday. You can, and I highly suggest, if you're able to, register for all three exams except for the 1020 students. You don't need to do the final. You only have to do the first two exams. So the 1030 and my single 1040 student should register for all of them. Please don't wait until the day before the finals to register for the final. That was a major nightmare last semester because I had like 3 or 4 students do that, and then they couldn't get a time to get in, and here I am scrambling with ITC trying to force you in, and yeah, it wasn't a pretty sight. So if you have your crystal ball out and see that you're available on this time, please register. Okay, so any questions so far on this stuff? I know last lecture was beyond boring. I'm sure I'd probably go look at the YouTube stats. I doubt anybody's watched the whole video, because it's just boring with a capital B. So anyway, so this tonight, and if I'm going to get out of here by 9, I don't want to go beyond 9 o'clock. So hopefully we can get done quick before 9. Tonight we're going to cover Chapter 5 in the 6th edition of MATLAB for Engineers by Dr. Holly Moore. This is a chapter on plotting. The objectives for this course according to the textbook, and I don't have a page number for that. I can get you a page number. It's like the first page in the chapter. I know that. But the objectives are create and label 2-dimensional plots. That's probably one of them. Well, I've actually used 3D plots too, so it's on the page with no page number on it, but the one after it is 157, so it's on page 156. So you'll create and label 2-dimensional plots, adjust the appearance of your plots, divide the plot window into tile chart layout where multiple plots can be displayed, and that objective number 5.3 is brand new to the 6th edition textbook. You'll be using tile layout command instead of subplot, and it's actually kind of cool. You'll also be able to create 3-dimensional plots and then use the interactive MATLAB plotting tools. So there's only 5 objectives, but man, there's 122 sheets or slides on the PowerPoint presentation for reference for the instruction. So anyway, okay, so we'll get right into this. Plots are, they're very, very important to engineers. We use plots at my office constantly. I'm plotting in SolidWorks. I have a third-party software called Electromagnetic Studies. I think it's EMS software. It's a finite element analysis that will simulate magnetic fields. I deal with magnets quite a bit, and from that it creates a lot of data. It creates plots within the software, but I can take that out and take the data and plot it into MATLAB. Plotting is very, very important. In order to plot in MATLAB, you have to have two ordered. Well, not necessarily. You can do it with a single array. If you plot just a single array, like, okay, so I put this in here so you wouldn't have to wait for me to plug all that data in. So that's all I've done is created a time vector and a distance vector. We can plot just a single variable, distance, and it will plot. And what it will do, if it doesn't have a second array, the time vector, it just takes the element number from this entry input. So the first element, the second element, third element, fourth element. But if you want a more precise based off of your data, okay, it doesn't change it out of the plot, but it does affect the scaling on your x-axis. So ordered pairs are usually used to identify points in a two-dimensional graph. And MATLAB will plot the points and then draw a straight line between the points to give you a line representation of the data. And these data points here can either be calculated. We can do 0 by pi divided by, we're going to make it really smooth, 100 to 2 times pi. And we're going to suppress that, and then p equals, let's just do the sine of theta. So those are calculated points. These here would be measured points. Let's say you had some kind of a sensor that every 2 seconds was taking a reading, and those were so that's the difference between a measured and a calculated point. But you can plot either or both of them. They both plot the same. It doesn't matter how the data points are generated. What? Oh, I got to run this before it'll plot. Stupid. I knew that. I was just seeing if you were paying attention. There we go. So there's a sine plot. So generally, the independent variable is given the name of x plotted on the x-axis. When you're putting the data points inputs into a plot command, whether it be a Cartesian plot, a polar plot, well, polar plots, okay, will be different, but your 3D plots, for a 2D plot, the first element entered is the x, the second is y, and then on a 3D, the third one would be the z. And I always have to look up polar plots because I can't remember whether it's theta first or r first. Polar plot. So, with SolidWorks here, so it's theta first and then the r. So anyway, again, the independent variable and then a dependent variable is usually given the value. Again, variables are user determined. You can name them whatever you want. Usually, it's best to name them something that's kind of, descriptive. I mean, we could call this a pig. Do a shift enter and it changes all my thetas to pigs, but it still plots the same. But now when we come back, we look at that. Well, what the freak is a pig? Okay, yeah, that's me. I'm a pig. So anyway, okay. So now we get into some basic plotting techniques. So Again, I kind of got ahead of myself here in the story. Oops. We'll get rid of those plots. So when you're plotting in an M file, so this one here is an M file. This one here is a live editor. When you're plotting in an M file, we'll come down here and plot again. It's the same. It's time and distance. So when you plot in an M file, it'll open up a new window, and it'll be labeled whatever the next figure is in its memory. It just keeps going and going and going. If we close this and open it back up, it still come back as figure 2 because I'd already done a figure 1. I'll get to that in just a minute. So now if you try and plot this and it doesn't pop up, you say, why isn't this working? Well, it did work. It's hiding behind the main program. So if you get lost and you can't find your window, it's just hiding. Another thing you can do is hit this little arrow up here, and it'll dock inside of your MATLAB. Okay, I don't like it there myself, but it's just like any other window in MATLAB. You can grab it and move it and move it. Come on, you know where I want you. Go where I want you. You kumquat. You can do it. It's just not always easy. Okay, they got to make this a lot easier. There we go. I like to put it down here so that it's with my workspace and so that I can see it and it's always there. So now if I do a close command, if you do close, it'll close that window. Obviously, we don't want to close it there because we want to see the plot. But when you plot it next time and you dock it, it'll go back into there. So close is a command that will close. If you do a close all, it'll close every window, plot figure window that's open. Let's bring this back up again. So that's figure 1. And to get into new figures, you can either just specify figure. That'll open up a new window. See, and it's window 2. And if we run it again, it'll be figure 3. Or if you want to specify the figure number, let's go to figure 7. You can just put the number that you want within parentheses. And then if you do a close all, that will close all 4 of those in one command. Well, let's say we just want to close figure 2. Figure 2 is gone. Or you can do close all. They're all gone. If you do just a single close, it'll close the last active window that was open, which will be figure 1. So if we get rid of the all, it'll just close the last active. And the same thing goes with another command here, is CLF, which is clear the figure window. So CLF, we can't do that if we're going to close it. If you just do CLF, it'll close clear the last figure, but this one's still here. Or you can CLF specific. Oh, don't do that. What? It's right there. Oh, because I didn't capitalize it, I think. Okay, you don't do that to me. Maybe this one didn't. Oh no, that's right. It doesn't. Sorry, my bad. I'm gonna have to edit this part out. In order to get that to clear just the figure, you got to activate. It only clears the active ones. So not active, you idiot. Do figure 7. That'll activate it and then clear it. That's what you had to do. Okay, but if you're in the live editor, the close feature works in the live editor as well. but you don't need to do the figure. So let's plot time versus data, a distance, and we'll also plot peg, and P. So in here it'll automatically, we need to run this again, and then come down here and run this. So in the live editor, it'll automatically put each new figure in instead of, well, let's see what happens over here if we don't do the figure. Let's close all. That shouldn't be capitalized, but it still worked. So now if we run this and we try to now come down here and, oh, we don't have pig. We're going to borrow this. Plot pig comma P. So it's still in the same figure. It just erased the existing plot and plotted the new one in. Whereas in the live editor, it created a new plot. Okay? Are you with me so far? Okay.
Yep.
Cool. Okay, so now let's okay, so now let's say we want to have these two lines represented in a single plot. Now there's a few ways for which to do this. Okay, so first way is with a hold on. So if you put the hold on, that's going to hold this figure, and then it'll plot this one, and then we'll come down here and say hold off. Now I don't know what these plots are going to look like. They should be, I mean, that's 18 and this is 1, so this is going to be almost a straight line compared to that one. But let's clear the figure window and see what happens. See, there it is, me, and see, it's all in one. So that's one way for which to get multiple lines into one plot. Another method is to enter them both in the same plot command. So if we have, and that each line needs a set of arrays, so the X and the Y, and then we'll go with the second X and the second Y, and we'll come down here and do another, and boom, and so here's this plot here. So both ways gave us the same thing. There is one other way which I really don't care for, but the book brought it up, so I guess I'm obligated to do it. You can create a new variable for both of the Y's. Oh no, but that is not going to work because the X's are different. Okay, so let's make our X's the same. So let's see, we have a pig. Let's make a cow the cosine. Cow equals cosine of pig. Oh, I guess the line was, see, and this is where making your variables names that are understandable, because it's my theta was changed to pig, not the y. But anyway, so now if we want to create a plot with both of those, we could say y is equal to, and we'll put in here p and cow. Okay, but those are both row vectors, I'm pretty sure. Let's see, workspace. P is 1 by 201, so yeah, so we want to, we'll just put these on 2 rows. And then we can come down here and plot pig against Y. And voila. Where's my plot? There's my plot. And so there you're able to do it all in one shot as well. A thing I don't like about this is, how close are we getting to that? Okay, that's the next subject up. Let's say we don't like these colors. Let's say we want to do different colors in here. So if we want to change the color of this line, we'll do a double quotation mark, and let's go to, oh, here's where I can't remember all this stuff. So we do a help and a plot, and this will bring up our options. Okay, so let's do a magenta. So that's going to be an M, and we want to have it do X marks on the points, on the data points, and we'll make it dotted. So that did that. And that's one way which you can control the color and the style of your line. And you can do that for each individual data point here. Let's go green, hexagonals, and let's do a dot dash. Dot dash. Ooh, that's a whole lot of data points to be doing that. I mean, there's 100 and what was there, 201 data points. So that kind of, let's get rid of our hexes and just do it without it. Okay, so oh yeah, see, I can zoom in here just by scrolling my mouse button. Say, wow, that's cool. So you can do that on individual lines, but you can't do it in this thing down here. At least you couldn't used to did it. I'm just going to change the color and see what happens. Oops. Boom. See, it applies it to all the lines, not just the individual line. So to get the individual formatting, you have to do either the hold on and change them in the same lines, or you can down here in betwixt these do the formatting each individual line. Let's go with that one, and we'll call that good. But you can't do it with this. Okay. Any questions? That was a lot to swallow there in just a few seconds. Okay. So again, remember, don't forget the help plot in the command window to help you. I only have 2 functioning brain cells, and for me to remember all this data here it's just not going to happen. I got better chance of winning the lottery than to remember that much. Let's see. To control the properties, specify the name, first data point, fields. You can get in and do some more formatting with a line width and marker colors and edges and all this other kind of stuff. If you want to get into that, just do the help plot or doc plot and pull up the help features in there, and it'll show you how to do all that. If you're still struggling, give me a buzz. I'll go on and see if I can't confuse you up a little even more. Okay. So let's say we want let's say we want this plot to only show between 0 and 3 on the X. So we can do an axis, and it requires 4 inputs. Your X limits 0, 3 and your y limits. And we'll go -1 to 1 to 1. Boom. And that will restrict the amount that is displayed. I mean, if all your data is still there, it's just only displaying between 0 to 3 because we cut it down using the axis command. If we want to add a legend to this, we'll do legend, and in here we'll do, and you can use either the character or the string input on your texts. The book is stressing that you really should use a string over a character, unless each individual character in your input has specific meaning. It just, I guess, less memory space. Of course, with computers today, it's not really that big a deal. But okay, so we have, I don't know which one. G, it was sign. And here's something that's coming up later too. If you do the backslash and a Greek name, it will type out that character in the display. And then we'll have cosine of theta. Oops. You forgot the stupid double quotation mark, you idiot. And then when we run that, we'll get us a nice funky looking legend box with the sign of theta. You can do a let's this point here is about 0.75 and 0.75. If you want to put text in your chart at a specific point, I believe it's the X point is going to be 0.75, the Y was 0.75, and then our text and then that will plot it on your plot. When we get into inputs and outputs, there's a G text, which there's some more stuff that we'll be doing with the plots when we get into inputs and outputs. Some other stuff we can do here, Y labels. Well, we can label our X's. X label is theta. Theta, and we want those in double quotations, not single. Sorry, it's for 100 years I've been doing single quotations, so it's, teaching an old dog new tricks. Now, okay, ooh, cool. Let's do this. We'll come back and do that. Okay, we'll do that. We'll do that in a minute. Okay. And then title, and I can't stress enough the importance of putting labels and titles on your stuff. I lost lots of points on one of the first reports I wrote when I got up to the University of Utah because I didn't have labels on it. And I says, well, it's in the text. He says, it's got to be on the plot, otherwise I don't know what it is. Okay, so I've been stressing to my students the importance. Okay, let's change this up here to cosine squared. Let's square this output. Okay, and then in our label down here, cosine, we can do a caret 2, and it'll raise it shows it as a superscript. And if f of x, let's do and there's no R in theta. If you use an underscore, it makes it a subscript. So those are some things that I just learned with the 6th edition textbook. There was something. Oh, what I showed my new textbook to our data analyst at my office, and she was really impressed with some of the new things coming out. But she come out and asked me, says, is there any way to put an underscore in the text? Because every time you do an underscore, it makes it a subscript. And I've played with it and played with it and played with it, and I even asked Holly, and we've determined that you cannot get an underscore in your text. If you do an underscore, so it gives you the double underscore, but it's not right. So if you guys figure out how to get a single underscore to come out in text, let me know. My data analyst would love to hear it. So if you want to add another line on here, okay, we'd put these in squirrely brackets separated by a semicolon and then another squirrely bracket, and then you'll have 2 lines in your title. I believe it works with labels too. Okay. Any questions, comments, wants, needs, desires, concerns, complaints? I'm hurrying here. We got 20 minutes to get through the rest of this. Okay, so something that is brand newbie to the 6th edition textbook that you will not find in the 5th edition textbook. If she would have done an update, I think a year ago, so it may have been in, but anyway, that's neither here nor there. So back in the olden days, whenever we wanted to have multiple figures on the same window, not necessarily in the same plot, we would do what was called subplot, which would give us, you'd specify how many rows and columns of plots you wanted. And if you did 4, you'd have 1, 2, 3, 4 plots. Well, that's been, it's no longer, it just, they don't do it that way no more. What they do is and we're going to do put a handle on here. It's called tiled layout. And we're going to go flow. Okay, flow just says that it's going to automatically pick where to put the next plot so that it looks nice. And then we will go next tile, and we'll do our plot of pig and pea, and then I think this is right. Title, double sign, and I'm just going to do X. And then to get our next, there's 2 T's in there, next tile, and then we will plot our pig versus cow. And title, and you can put labels on these at the same time and all that other good stuff too. Oops.
Hey, Art.
Oh, good golly, you scared the bejeebies out of me.
Sorry.
It's all right. Wasabi.
Oh, do you need double quotation marks around flow?
Yes. And so if we were doing this in let's see here, let's gather all of this up. I don't want to take the time to redo all this, so I'm going to cheat and come up here and do a copy and bring it over here and do a paste. So this here is, we're not using that part. I just want to show the two plots in a single. Oh, here it is. So there we go. And see, we used to do that with subplots. Ooh, let's do a parametric plot here. Next tile, and we're going to plot P versus cow. Okay. There's more to this. This, like I say, this is new to me. So the fact that I got this far with only the one mistake, I'm really happy. Yeah, cool. Oh, and then down here, here we're going to cheat and borrow this and see if this works. And by this here, we'll put a main title over the whole figure. Is that cool or what? Say, yeah, man, that is so cool. Oh. Okay. Yeah, sweet. So there is, hang on. There was one, where is it? Introduction to String Array, Chapter 4. No, I want Chapter 5, you idiot. Chapter 5. There we go. Hang on. Oh, here we go. If we wanted these two up on the top and this one down below, okay, this is what I didn't know, is that you can specify here on the next tile the 3, and I will have to look in to find out what exactly these inputs represent. But that gives you the 2 up here. I'm guessing that this is 3 with a 1 by 2. But that don't, because I'm 2. So I'll need to look into that and find out what the 3 and the 1 and the 2 represent and get back to you. Oh, maybe we can look over here. Next tile. What? Well, that was no fun. I want help with next tile. Oh, there we go. Let's see here. Let's see, documentation. I think this here is spanning that wants. I want it to go over 1 row and 2 columns, and this may be the 3rd chart. I don't need you open anymore. Why do you open it? Don't say. Okay, I think that's what it is. I will get back to you and make sure one way or the other, because for some reason this didn't open up. There it goes. Okay. It's new stuff, so I'll get back to you. Cool. So where are we at here? Okay, we are okay. So right here, it specifically states consult the help feature for more information on how to use tiles. But you should probably practice using it on simple tasks before moving on to more complicated jobs. So this one would be more complicated. So anyway, okay. So although simple XY plots are most common type engineers, there are many ways to represent data in plots depending on the situation. There may be some more techniques that are more gooder to use than an XY plot. Polar plots, logarithmic plots are great for exponentials or polynomials. You do logarithm, it'll plot it as nearly a straight line. Bar graphs, pie charts, histograms, plots with two different y-axes. You could have this scale on this side and another scale on the other side. I'll do an example of that here in just a minute. And then function plots, which is the F plot, which you asked about at the beginning. I'm running out of time, only got 10 minutes left. So in order to do polar plots, it used to be just polar, but now you have to do polar plot. So let's do theta equals 0 by pi over 6 2 times pi, and then r is going to equal let's do ones, 1 and the length of theta. That should make them both the same size. Let's see here. What? Oh, there's no p and 1s? When did they change that? Oh, man. Oh, let's do a clear up here. Enter. There we go. So yeah, so they're the same. So now we'll do a polar plot with theta first and then r. And here is our funky looking polar plot. Where is it? Oh, we're down here. Again, it did this because it was still thinking it's in this mode here, and I get that in the homework all the time because there's some homeworks where you got to do the layered tile layout, and then we don't do a clear figure, and it just puts it in the last active figure it had. So anyway, so there's your polar plots. Remember that it's theta first, followed by r, and they, as with all other plots, they have to be of the same size, same number of elements in each one. So there's semi-log x, semi-log y. It puts what can we use there? Oh, we've cleared all this stuff out here. Well, I don't have a good function to do those, but semi-log x, semi-log y, log y, not log y, log is the logarithmic scale on both the x and y axes. You have bar charts. Bar H makes a horizontal bar graph instead of vertical. 3D bar chart. I guess we could. Oh, let's come back up here and let's run this and do a bar of distance. Did I spell that right? No, there's too many A's in there. So there's your bar chart, and here's a three-dimensional bar chart. Wow, that is just cool. Pie charts, pie distance. Oh, dimensional, and I got 6 minutes here. Okay. Okay, let's do the let's come down here and we'll do the dual axes, a sample on the dual axes here. I have an example here. So we're going to create x is equal to 0 to pi divided by 20 to 2 pi. Where's my times button? Somebody keeps rearranging my keyboard. So we'll have y1 is equal to, we did these already, sine x, oops, and y2 is equal to cosine of x. Okay, and then we'll do the so to get them. Oh, let's do everything here. Let's do it all. We're going to close all the windows, clear the command window, and clear. Okay, so now we're starting off fresh. Okay, so now what? We're going to do a YY axis. Oh wait, yeah, this YY axis. So this puts all left. I think it defaults to the left, and we'll plot X and Y1, and you can do your labels and titles and all that, or well, your labels, and then we'll do YY axes right and plot X and Y2, and cross our fingers and hope it don't explode. Oh, this is live editor, so it's kind of meaningless because they're both the same. You know, we could come down here and do x equals x. Oops. Let's go x2 equals x. Make it 8 times as high. And plot x2 just to show that it does actually make a difference. Whoa, that just changed. Oh, dang it. Yeah, because of output. That's not what we wanted, you idiot. I knew that. I was just seeing if you were paying attention. We want to multiply this by 8. See, now we see we got a different scale on this side than we have on that side. And this is where it comes in handy, because if we just did a, let's see what happens if we plot those on just x, y1, and x, y2 times 8. Cool. We got a holdover of that one. Oh, because we're still on the. Let's do. There we go. Because it was still doing the dual. Well, we want it. Oh well, yeah. So if this was even more extreme, let's go 80 and 80. You see, you can see both lines, but you come down here. This looks like a straight line. I hope that kind of helps see the benefit of having two different scales on the y-axis. Okay, any questions? Did y'all fall asleep? I was talking to my daughter, was it last night? And she fell asleep on me. I'm sitting there yelling and screaming, and it's nothing. She just sound asleep. I guess it shows how boring I am.
So it'll work.
Okay, cool. Not me. I fell asleep about 3 hours ago. Okay, so one more thing we'll cover here is the f-plot. So f-plot requires three inputs. It requires a function and the range of where to plot it. I guess that'd be two, but three because you got you got a beginning and an ending point on your range. So we can do this all in here, but you have to create what is called anonymous function. That was the word I was looking for. 1 to 3. I think that's the proper out. So this is an anonymous function. It's used inside of a main script file for something that you're going to use over and over again, but you really don't want to keep it for use outside of the function, so it's just an anonymous it's function. So you write this, and then anything that comes after it, you just type in f, and it'll give you the sign of x. Obviously, you would use it for something a little more intense than just the sign function. But with the f-plot, it requires a function here, and we will get into functions a little bit more in the next chapter, and then the range. If I did this right, we should have a plot. No, we don't. Oh, crumbly. That's what I said. F-plot. That's what I did. Oh.
Maybe you don't need the F in front of the...
Oh, it could be, yeah. There we go. Yeah, but if you, oh, maybe I didn't. Maybe that. Oh man, I'm tired. Okay, so that's f-plot. That works with any function, whether it be a user-defined function or a built-in function. You just got to give it a handle, and then it'll plot. So 3D plotting. Let's see. Do I have an example handy here? I don't have one handy. Let's see if I can remember here. Let's too many R's or E's in there. Let's have x equals 1 by 0.5 to 100. Y, I don't know what kind of plot this is going to give us, is equal to x. We're going to make those the same size. And then we're going to mesh them together. X comma y comma equals. Mesh grid, you should remember mesh grid from chapter 4. And then z, this is the equation I don't quite remember, but I'm going to let's go with the sine of the square root square root, come on, you can do it, there you go, of x dot raised to the 2 plus, where'd my plus button go? Y dot raised to the 2. And we'll suppress that. And now we got 3. So there are several different types of plots you can do. There's a surf plot, x, y, and did I do a lowercase or an uppercase z? I did a lowercase. So this will give you what the surface of that plot looks like, and that is pretty ugly. Okay, that's not going to do it. Let's see what a contour. There's no U at the beginning of that, you idiot. Well, that's kind of cool. Is that cool or what? Say, yeah, that's cool. And what other we got? Oh, we got mesh. And that looks as like bad as the first one. And the 3D plots will take, like I said earlier, just a single input. We can just put in Z, and it'll give us the same thing. It'll use the index numbers as the X and the Y coordinates. So yeah, cool. And then there's shading that you can do to it, and colors and all kinds of other fun, neat stuff. Okay, I went 6 minutes over. I covered everything that I wanted to cover for the day. There, like I say, there's a lot of information in this chapter, but it's pretty. I don't know. I hate to say that it's easy. It's basically the same thing over and over. You just gotta, there's just a lot of plots. Copy and paste is your friend on this assignment. Any questions, comments, wants, needs, desires, concerns, or complaints?
We're good for now.
Yeah, good for now.
So, okay, now I'm going to pause.